Alright, so this is for week 7, day 3. We have 2 lessons together. We'll do the area and surface area and volume, but first we'll do our minute 72. Number 1. Marty got a score of 45 with 2 throws on a dartboard. Which 2 categories did he hit? So he has a total of 45. So it needs to be in 2 throws 45. So 30 and 15 is 45. You don't really have another combination with 2 throws. So 30 and 15. Find the area of one of the triangles. So remember, so this is what we've just been working on. When you're finding the area of a rectangle, it's base times height. When you find the area of a triangle, it's base times height divided by 2. And so I'll zoom this in just a little bit, sorry. So base times height divided by 2. So base times height, which is 50, and because this is a triangle, we're going to divide it in half, which is divided by 2, which half of 50 is 25. And they don't give a unit for whatever reason. It always makes me kind of irritated. So the area would be 25, and I added an m, and I'm gonna put meters squared, because it is important to know that the units squared is what represents area. Alright, complete the chart. Fraction, decimal, and percentage. If you have 5%, so out of 100, it would be 5 hundredths. And if it's a fraction, 5 hundredths would look like 5 out of 100 or 1/20. Either way. And that kind of reminds me, just to hit something that you guys might make sense. This is like a nickel. If you had $1, how many nickels would it take to get to $1? It would take 20 nickels. So if you had one of those nickels, you would have 1 out of 20. These letters are put on cards, and then one card is drawn at random. What is the probability that Y is drawn? So you have 1, 2, 3, 4, 5, 6, 7, 8 total. And it says, what is the probability that Y is drawn? So I'm going to go through and just circle every Y. And that's it. So I have 3 out of 8. What is the odds that you would have 3 out of 8? Which of these numbers would solve both these equations? So we need to be able to substitute either the 3, the 10, or the 2 in for the x, and it should be equal. So if we were going to put this here, and let's say we put a 3 here, 2 times 3 is 6, plus 7 equals 13, so that part's true. 6, now we're going to put the 3, the same one. 6 times 3 is 18, take away 5 is 13. Well, that solves both. Let's just double check and make sure. 10. 2 times 10 would be 20, plus 7 would be 27, which does not equal, so that does not work. And then let's substitute 2 in. 2 times 2 is 4, plus 7 is not 13. So the only one that worked was the first one. Yay! They were kind of nice. Okay, all of the following equals 5 except 4. So this actually, I haven't really talked with you guys much about this, but this symbol right here means absolute value. So when you see this, that absolute value means the distance to 0. So if I said, what is the distance from negative, if I showed the absolute value of 1001, negative 1001, it just means how far is 1001 to 0? Well, the answer would be 1001 spaces. So it's just, it will always be positive. It's always a positive number from that number to the 0. So this one's equal to 5. All of the following are equal to 5 except for the square root of 5. Remember, square root is any number times itself, so 5 times 5, that works. This would be 5 times 5 times 5 times 5 over 5 times 5 times 5. And you would cross out the ones they had common. 5 over 1 is the same as 5. There we go right there. That one won't be it because 5 times 5 is not 5. It is, in fact, 25. So this one does not belong. Nope. If 5/8 times a equals 1, so we need to get to a whole, then a equals, so if you're looking at that and it says, if you need to get to 1 and you're multiplying, so we would have to get a whole number that would go over here. Let me grab, sorry, I think I just shoved it right down there. Oh, sweet Perry. Where are we at? Number 7. The thing that gets you here, so that gets me here, is that they don't show this as a fraction. So a is just any number. Whatever you have to do, when you have 5 over 8 and you multiply it by a number and you want to get to 1, whatever you would multiply the top by, so you would just flip this and go 8 over 5, because this number times this number will be the same. 8 times 5 is 40, and when you multiply fractions you just go straight across, and 8 times 5 is 40. And 40 over 40, no matter how big those numbers are, still equal to 1. So a is 8 over 5. The thing that concerned me with this one is that they showed a as just a single variable, and I didn't know if they were, what their thoughts were on why it wouldn't be set up differently, but that's okay. So this number 8, I know that it says cross out the common factors on the top and the bottom. I've talked a little bit about this. This is why you have prime factorizations. So you have prime factorizations because you're identifying what numbers they have in common. And you can cross whatever you can cross off one on the bottom and one on the top, when in reality what you would have, I don't have, there we go. If you wanted to know what all those numbers were multiplied out, I will just get my calculator out and show you. We have 2 times 3 times 3 times 5 times 7 equals, this would be 630. 3 times 5 times 7 equals 105. So if you were to do the prime factorizations of these numbers, 630 and 105, you would get these numbers. These numbers make up all of these numbers. This number makes up that, and these numbers make up that. So when you simplify a fraction, you cross out the common multiples that they have, or the common factors. And in fact, they have a 7 in common, a 5 in common, and a 3 in common. That means there's nothing left on the bottom, but that does not mean it's a 0. You actually hold it as a 1 because anything times 1 would be itself. So you would just have this left over 1. So we would in fact have 2 times 3 over 1, which equals 6 over 1, which is the same as if I had 1 slice makes a whole, I would have 6 wholes, or 1 piece makes a whole, makes 6 wholes. So your answer would be 6. Change to an improper fraction. This is what we were doing right before school got out. And you multiplied, we kind of did the C thing, and I keep telling you, like, you're clockwise, you're undoing it. We're going to add from the bottom, clockwise, undoing it. You're going to multiply and add. Clockwise, undoing it, multiply and add. When we do this, I'm going to go 5 times 4 is 20. And actually, just so you know, right here, I don't do anything with this the denominator. It just stays the same. So I'm just going to leave these right now. If they told me to simplify, that would be different. But they don't. So I'm just going to carry them across. 5 times 4 is 20 plus 1 is 21. 5 times 5 is 25 plus 3 is 28. 10 times 1 is 10 plus 9 is 19. These are the improper fractions. The improper fraction, remember, is when the bottom number is larger or smaller than the top number. You have more parts than you have wholes, or than make a whole. This is, number 10 is, when you have parentheses and you don't see a symbol, that is implied that you multiply. And when you multiply a fraction, the easiest thing, you multiply straight across. So 1 times 2 is 2, and 3 times 3 is 9. Now this one, the little tricky, they have you a negative number right out here. You're just, if you only have one negative number, if this was a negative and that was a negative, your answer would be positive. Because this is a negative number, you have to have a negative. So it's like, if you're ever multiplying and you see a negative, you're going to have another one. So I just go ahead and put that over there, and then I'm going to forget about it. And I'm just going to multiply across. 2 times 4 is 6. No, it's not. Oh, stars, I almost messed that up. 2 times 4 is 8. And 5 times 7 is 35. This is my answer to number 10. 2/9 and 8/35. Negative 8/35.